So let's start. Circular motion. Uniform circular motion. No. Later. Let us finish it. Then I'll give you some extra time. Do. Okay. What is uniform circular motion? To understand uniform circular motion, be serious. We have to finish it. We just start from the motion of particle in a circle. Not telling uniform circular motion or not. We need to understand the displacement, angular displacement, angular velocity, angular acceleration, all these things. Particle is in UCM, means its speed will remain the same at all points. Before doing that, let us remember an important relation in trigonometry, that is, this arc length AB and this radius BR, angle B delta theta, then this arc AB, all of you have done in trigo, is equal to R into delta theta. You can take this length, this arc length, as delta S. Why I am telling this mathematical relation in the beginning? Because it plays important role of deriving a relationship in circular motion or uniform circular motion. Now, when the particle goes from A to B along this circumference, is there any difference between this distance along chord and distance along arc? Can I take under any condition arc AB equal to chord AB? We can, if those 2 points are very close. If they are very close, then chord AB, arc AB equals. Otherwise, no. Otherwise, there is a difference. So, when a particle goes from A to B in circular path, we can say that displacement is AB, but distance is travelled along the circumference, which is given by this relation R into delta theta. Clear? So, displacement of a particle in circular motion is defined as displacement. If you define, then it will be in a fixed time. So, displacement, we say angular displacement. We say angular displacement. Angular displacement of a particle is equal to the angle described at the center of the circle in a fixed time. That's why it is displacement. Time you have to specify. If you don't say fixed time, then it is not angular displacement. Okay? So, angular displacement is the angle described. This is angular displacement. What is the linear displacement? Linear displacement in this time. So, let a particle describes an angle delta theta at time delta t. Let a particle describes an angle delta theta at time delta t at the center of circle of radius r. Particle going from A to B. Then angular displacement is equal to delta theta. What is the linear displacement? Linear displacement is AB, but we will be defining it along the circumference of circle. So in that sense, it is not displacement, it is distance. Okay, some confusing situation will arise here. I will be referring AB as displacement, not distance. Displacement is chord AB, distance is AB. And what is the direction of that displacement, if you see? And what will be direction of the velocity it has? In circular motion also it has velocity. What is the direction of that velocity? Gradually I will explain all those things. Every time will not be very clear here. The direction of angular velocity finding is very difficult for you at this moment. That will find in rotational motion. Okay? So here angular displacement delta theta will be referring as linear displacement delta s, and by using trigonometry delta s equal to r delta theta. Okay, delta s is the linear displacement, or you can write s equal to r theta. In the sense of motion in 1D, what we have learned, displacement is equal to radius into theta, unit of s and r same. Theta should be expressed in radian. Okay, it is actually not equivalent to the linear displacement. Please keep this in your mind. Along the circumference of circle, the displacement of the particle is s, which is given by r into theta. Theta should be in radian, then r will be in meter, and s also will be in meter. We can state this is the relation between angular displacement and linear displacement. At this moment I have no answer. If you ask me what is the direction of angular displacement, you hesitate to answer linear displacement also, then answer my question, what is the direction of angular displacement? Angle it is described in the sense of vector. What is its direction? I will remain silent at this moment. Okay, we will define all these terms. These are rotational mechanics quantities. In rotational motion we will define, because we have to learn some other terms also there based on this concept. Here you assume that delta s is linear displacement, delta theta is the angular displacement. We will never specify the direction here. No one does. Okay. So based on this, can you define angular velocity and linear velocity? Let us define angular velocity. Again I tell you, direction we cannot define, but angular velocity we will define. This is denoted by the letter omega. Angular velocity is defined as rate of change of angular displacement. Okay. So omega equal to delta theta by delta t. Limit delta t tending to 0. This is going to be d theta by dt. Okay. So angular velocity will be expressing by this term omega equal to d theta by dt. So this is a relation you have learned. What is the unit of omega here? This is our number 1 relation. This is number 2 relation. Unit of omega. This will be rad per second or revolution per minute. Unit of omega will be what? Theta by t. You say radian per second, or it is revolution per minute. Radian per second sometimes will be referring as RPS. Revolution per minute will be writing as RPM. Okay. Now, what is the relation between RPM and RPS? Let us write first. Relation between RPM and RPS. 1 RPM is 1 revolution per minute. 1 revolution is 2 pi radian. Hope all of you know it. 1 revolution in circular path is 2 pi angle. It describes 2 pi by 60 rad per second. Never forget. 1 RPM 2 pi by 60 RPS. Clear? 1 RPM is 2 pi by 60 RPS. So angular velocity is understood without understanding the direction. For the sake of 11th physics, at this moment we are doing it. Now, can we find the relation between linear velocity and angular velocity? Linear displacement we have defined, so let us do it. Relation between V and omega. V and omega. Let us start from this relation. We have S equal to r theta. S is the linear displacement. So differentiate both sides with respect to t. ds by dt will be what? R d theta by dt. What is ds by dt here? V. And d theta by dt is omega. So therefore, linear velocity equal to r into angular velocity. Clear? So V equal to r omega. Now we'll decide the relation between, okay, let us define angular acceleration. Again, about direction, at this moment we will remain silent. Angular velocity. It is angular, oh my god, this is angular acceleration we are going to define. Angular acceleration is what? Alpha. This is equal to rate of change of angular velocity. that is d omega by dt, or d dt of d theta by dt, d square theta by dt square. Clear? So alpha is d omega by dt or d square theta by dt square. Then unit of alpha. What will be the unit of alpha? Omega is rad per second. So rad per second per second. It is rad per second square. Clear? Alpha. Alpha is the angular acceleration. Now we are going to define uniform circular motion. Let us define it first. Uniform circular motion. What is that? A particle in uniform circular motion means uniform circular motion, it means its magnitude of velocity remains the same at all points, but there will be change of velocity vector. Okay, so let me define by the term UCM, we mean the kind of circular motion, where the magnitude of velocity remains the same. This uniform circular motion, we mean the kind of circular motion where magnitude of velocity remains the same at all points. I'll answer all the questions. Wait. So if we say that velocity at this point, it is going from the point A to the point B. Okay? Describing an angle delta theta at the center. Okay? Here velocity is v1. At a particular point, velocity will be tangential. That we are defining. v1 velocity, v2 velocity, this manner. Okay? And it happens in time delta t. Now, let us write this. Let in going from the point A to the point B, a particle describes an angle delta theta at the center in time delta t. Okay? And velocity changes from V1 to V2. And let us assume that mod V1 equal to mod V2 equal to V. The magnitude remain the same. So let this thing mod V1 mod V2 is equal to V. But due to the change of direction, the velocity vector changes. You agree or not? Due to change of direction, the velocity vector changes, isn't it? We are interested in finding that change of velocity vector by time. Let us find V2 minus V1 by delta t. It happens, delta theta in time, delta t we have assumed. We want to find this change of velocity over the time. We will get the acceleration. Now, how to find? And this will be acceleration under the condition when delta t tending to 0. We have to find this. But how to find this? Change of velocity. To find this portion, that change of velocity, or limit delta t tending to 0 delta v by delta t, we take the help of vector. These are two vectors. We have to find their difference, V2 minus V1. Let me work on this diagram first. You produce this one forward, produce this one backward. This is the point O. Here the meeting point is O dashed. Okay? Clear? The diagram is obvious. Now, tell me how to find that difference. Let me draw a bigger diagram. This is not working. This is our V1, this is V2. Vector subtraction, all of you know. We are going to find limit delta t tending to 0, delta v by delta t. Okay? OAB, yes, this is our same diagram I am taking, delta theta. To find the difference, I am producing this one backward. Let them meet at the point O dashed. So this is the direction of V1 and this is the direction of V2. The difference V2 minus V1 I will find in different triangle. Finding here V1, this is V2. Can you tell me what is the angle between V1 and V2? This is delta theta, this portion 90 degree, this is 90, so this has to be equal to delta theta. So angle between V1 and V2 what? Delta theta is the angle and this is the point O dashed. But where do you get the difference? V2 minus V1, how to find? Will you go by triangle law or by parallelogram law? Same thing, no? Triangle or parallelogram doesn't matter. Here we are taking triangle law. You just join these two. Then can you tell me which portion in this triangle? This is a new triangle. Where do I find V2 minus V1? This is V1 vector, I told. V2 vector, how can I find the difference? You understand how V1, V2 taken? Same thing I am just taken over there. So this is V1 and this is, in this triangle, O dashed, A dashed, B dashed, O dashed, B dashed equal to, am I correct? What is O dash B dash? Tell. V2 vector, V1 vector. What is A dash B dash vector? Tell. What is A dash B dash vector? A dash B dash vector will be what? That is going to be V2 minus V1. See, this you keep A dash B dash vector. This is vector diagram. Therefore, A dashed B dashed is V2 minus V1. Why I am so interested writing V2 minus V1 or A dash B dashed? Because if I can find this length, my objective is to get this thing, no? Delta V by delta T. Delta V is what? In this diagram, this is going to be delta V now. Therefore, delta V equal to V2 minus V1. Write your comment here. So in triangle O dashed, A dashed, B dashed, A dashed, B dashed represent the change of velocity. Change of velocity, that is delta V. It represents delta V. Okay? Clear? And that will refer as acceleration. A equal to what then? Mod delta V by delta T. Isn't it? But A dash B dash we have to find. A dash B dash not found out. Just see one thing here. OAB and O dash A dash B dash, they are similar. Do you think they are similar? In this diagram, OAB and O dash A dash B dash are similar. Okay? So we write triangle OAB similar to triangle O dash A dash B dash. Why? Because you just check R by R is the ratio between two sides. And what is this? O dash A dash by O dash B dash is what? Mod V1 by mod V2. Mod V1 by mod V2 is what? They are equal. Magnitude of velocity remains the same. It is becoming 1:1. And R is to R is 1:1. Two triangles are similar if their corresponding sides are proportional. But this proportionality can be understood another way also. If two sides are proportional to two sides of another triangle, interior angle same, they are similar. They are congruent also. But here the ratio same. That's why we will not say congruent. They are similar. R by R, R is never equal to mod V1. If it happens, it will be occasionally. Other R by R 1/1, mod V2 by mod V1 also 1/1. So that's why I told they are similar. If they are similar, then corresponding sides should be proportional. So A dash B dash by AB going to be, you agree? A dash B dash is this. So this angle delta theta, this one delta theta, this by this equal to this by this. This is shown in diagram only. So delta V by AB is what? Tell. AB is what? AB we don't know. Or we know it. Check. A dash B dash by AB. O dash A dash is what? Mod V1, I mean V by OA, that is R. We have taken mod V1 mod V2 equal to V, because magnitude same. So mod V1 mod V2 equal to V. Therefore, delta V equal to V into AB by R. Am I correct? Clear?
Yes.
Now divide both sides by delta T. Divide by delta T. We need to get delta V by delta T, no? Divide both sides by delta T. Delta V by delta T will be V into AB by V by R, and this is delta T. We have reached till this step. Under what condition arc AB and chord AB they are equal? When B is very close to A, when delta T tending to 0. So after writing this, you have to mention it. Now, when delta T tending to 0, B is approaching A, that is arc AB going to be equal to chord AB, isn't it? So put delta T tending to 0 on two sides and put delta T tending to 0 over there also. Okay? What is this thing? It is dV by dt, V by R, and what about this thing? This was chord AB, no? This is this is chord AB, but chord AB equals what? R delta theta. So write limit delta T tending to 0 R delta theta by delta T. Right side you have to simplify. V by R into d theta by dt. So V into omega as so this acceleration A equal to V into omega value is what? V by R. So put, so A going to be V square by R. This is called centripetal acceleration. So what will be centripetal force? Fc. What is the centripetal force? It is going to be m into AC. We don't need force. For the first chapter of class 11, we need only this expression. Is that clear? Clear? So in uniform circular motion, centripetal acceleration is V square by R. Now a most important question after this topic, just after deriving the expression, that this acceleration will be directed in what direction? You said acceleration is there, it is centimeter. Now in circular motion, but this acceleration exists and it's a vector quantity. And very interestingly, this acceleration will be directed towards the center. That I can give you the proof logically. This centripetal acceleration, when the particle going with uniform velocity, is V square by R at any point It is v square by r. I did not specify any particular point. At this point, acceleration v square by r. Why? Why I am taking towards center? I will tell you. Towards center. Every time it is v square by r towards center only. It is centripetal, that's why. Automatically you will ask me a question, why towards center? Why you are not taking it some other direction? It cannot be in other direction. We can prove it logically. What is the logic? Suppose centripetal acceleration at the point A or B or C not directed towards center. Prove by contradiction. Let centripetal acceleration be directed this way, AC. If possible, you are writing the answer to this question. Why FC is, AC is directed towards the center. Why centripetal acceleration is directed towards the center? If possible, let AC be directed as shown. Okay, let it be directed as shown in diagram. If directed this way with tangent, suppose it is making some angle alpha. What is the direction? What is the component of acceleration this way? AC cos alpha. What is the component this way? AC sin alpha. Isn't it? So AC cos alpha will not allow it to maintain the constant velocity. Velocity, you said at every point magnitude remains the same. Acceleration is due to change of velocity vector. It is going from this point to this point. What is changing? The direction of velocity vector. Due to change of direction of velocity vector, there is acceleration. I just tell you one symmetry. You are going 10 meters per second this way. Then you are going 10 meters per second this way. Is there any change of velocity? You are going towards east with velocity 10 meters per second. After 20 seconds, you are going towards south with velocity 20 meters per second. Question, is it changing? The velocity is changing? Yes, changing. You can't say it is 20 minus 20. You have to say that it is 20j minus 20i, something like that. It exists. And that difference you have to get by parallelogram law. So here, if the acceleration directed some other direction, a tangential component will increase the velocity. It will not be able to maintain uniform circular motion. Am I correct? That's why it will be directed towards the center. Clear? You understand? All of you understand?
Sir, if